Welcome to the Ultimate TypeScript course. In this course, I'm going to teach you everything you need to know about TypeScript, from the basics to more advanced concepts. So, by the end of this course, you'll be able to use TypeScript to build large-scale applications. If you're looking for a comprehensive, easy-to-follow, well-organized, and practical course that takes you from zero to hero, this is the right TypeScript course for you. Everything you need to know about TypeScript is in one place, so you don't need to jump back and forth between random tutorials. Let's jump in and get started. Let's start by talking about the top 3 questions people usually ask about TypeScript. What is TypeScript? Why do we need it? And how is it different from plain or vanilla JavaScript? Well, TypeScript is a programming language created at Microsoft to address some of the shortcomings of JavaScript. You can think of it as the sibling of JavaScript. JavaScript is like a kid without any discipline, who does whatever he or she wants. TypeScript, on the other hand, is like a kid with some discipline. Technically speaking, TypeScript is a programming language built on top of JavaScript. This means that every JavaScript file is a valid TypeScript file. However, TypeScript adds some really useful features to JavaScript that help us build more robust and maintainable applications in less time. The most important feature TypeScript offers is static typing. So, what does that mean? In programming, we generally deal with 2 kinds of languages, statically typed and dynamically typed. In statically typed languages like C++ and Java, we know the type of variables at compile time or while we're writing the code. For example, we can declare a variable of type integer, and that variable can only hold integer values, nothing else. We cannot assign a string or any other type of value to it. In dynamically typed languages like JavaScript, Python, and Ruby, the type of variables is determined at runtime and can change. This means we can declare a variable, assign a number to it, and later assign a string to the same variable. That variable doesn't have a fixed or static type. The type is determined and can change while the program is running. While this flexibility can be useful, it can also lead to problems. For example, what if we pass such a variable to a function that expects a number? Then, our application might behave unexpectedly or even crash. The issue here is that we won't know about these problems until we run the application or our unit tests, assuming we've even written those tests. This is exactly the kind of issue TypeScript aims to solve. TypeScript is essentially JavaScript with type checking. With TypeScript, we explicitly define the type of our variables when we declare them, just like in statically typed languages. Then, we pass our code to the TypeScript compiler, which checks for any type-related errors. This means we can catch many mistakes during development before running our code. For instance, if we declare a variable as a number, we cannot later assign a string to it. The TypeScript compiler will immediately flag this as an error before the code is even executed. So, we don't need to run the application or rely entirely on tests to catch these kinds of bugs. Many of them can be caught simply by compiling the code. But TypeScript is more than just type checking. Most modern code editors provide excellent support for TypeScript. They can detect the types of variables and offer useful features like code completion, refactoring suggestions, and in-editor documentation. Additionally, TypeScript includes features that allow us to write cleaner and more concise code. Over time, many of these features do get added to JavaScript itself. However, because JavaScript runs in various browsers and environments, it often takes a while for these features to become widely supported. By using TypeScript, we can start using the features of future JavaScript today, without waiting for browser support to catch up. In short, TypeScript is built on top of JavaScript, and can be used anywhere JavaScript is used on, the front end or the back end. Anything we can do with JavaScript, we can also do with TypeScript. That said, TypeScript isn't perfect. There are some drawbacks to consider. First, there's always a compilation step involved. Since browsers don't understand TypeScript code directly, we have to compile our TypeScript files into JavaScript. This process is known as transpilation. Second, working with TypeScript requires a bit more discipline. If you're a developer who prefers to move quickly and skip strict structure, TypeScript might feel like it's slowing you down. And in a way, that's true. But if you're working on a larger project with multiple developers, using vanilla JavaScript will likely lead to more time spent debugging and fixing unexpected issues. In such scenarios, TypeScript can actually save you time in the long run by catching mistakes early. Of course, for small or simple projects, you can still use vanilla JavaScript if that's what you prefer. Alright, that's the overview of what TypeScript is, why it's useful, how it differs from JavaScript, and what trade-offs you might encounter. Next, we're going to set up our development environment and start writing some TypeScript code. Alright, the first thing we need is Node, because we're going to use the Node Package Manager, or NPM, to install the TypeScript compiler. I believe that, as a student of this course, you already have Node installed on your machine. But if not, head over to nodejs.org and download the latest version from there. Once you've done that, open a terminal window and run the command npm. This stands for Node Package Manager, and we'll use it to install third-party packages, in this case, the TypeScript compiler. To do that, we type npm i g TypeScript. The I is short for install, and the G flag means we want to install TypeScript globally, so that the compiler is accessible from any folder on your computer. Then, of course, we specify the name of the package TypeScript. Once that's done, we can verify the installation by typing TC is short for TypeScript compiler, and the V flag shows the installed version. For example, I'm currently running TypeScript version 5.8.3. You might install a newer version, but don't worry, everything I'm going to teach you in this course will apply to newer versions of the TypeScript compiler as well. Now, in this course, just like in my other courses, I'll be using Visual Studio Code, or VS Code, as my code editor. You're welcome to use any editor you prefer, but if you want to follow along and take advantage of the shortcuts I'll be showing you, I highly recommend using VS Code. Alright, now I'm going to go create a new folder for our project called TS Course. You can call it anything you want, and you can place it anywhere on your machine. Once that's done, let's go into this folder and open it with VS Code. To do that from the terminal, we type code. The period refers to the current directory. If this command doesn't work on your machine, you can simply drag and drop the folder into the VS Code window. Now that we've opened our project, let's add a new file and name it .index.ts. Every TypeScript file should have the .ts extension. Earlier, I mentioned that TypeScript is built on top of JavaScript. That means TypeScript is a superset of JavaScript. It includes everything in JavaScript, plus some additional features. So we can write regular JavaScript code, and it will be valid TypeScript code. Let's start simple. In index.ts, we'll write console log hello world. That's it, basic JavaScript, and also valid TypeScript. Now we can go back to the terminal window, or we can use the integrated terminal inside VS Code. To open it, go to the View menu and choose. This opens a terminal at the bottom of the VS Code window. With that open, we can use the TypeScript compiler to compile our index.ts file. We type tsc index.ts. This command will compile our TypeScript file and generate a new file, index.js. Let's take a look at the output. Since we didn't use any TypeScript-specific features, the generated index.js file looks exactly the same. It just contains the console log statement. That's expected. Now, let's write a little actual TypeScript code. In index.ts, let's declare a variable using the let keyword. I'll call it age and annotate it with a type of number. This is how we annotate variables in TypeScript, by adding a colon followed by the type. Here's the beauty of this approach. Because we've explicitly declared age as a number, we cannot assign a string or any other type to it. If we try to write age equals 20, TypeScript will immediately show an error. TypeString is not assignable to type number. This is the power of TypeScript. It helps us catch errors at compile time, rather than at runtime. We don't have to run the application or write tests just to find out that we've mistakenly assigned the wrong type to a variable. So, let's remove that incorrect line and recompile the file. Go back to the terminal and run tsc index.ts again. Now let's inspect the generated index.js file. You'll notice something interesting. Instead of let, we see var. That's because, by default, the TypeScript compiler targets an older version of JavaScript called ES5, short for ECMAScript 5. Just to clarify, ECMAScript is the specification, while JavaScript is the implementation of that spec. ES5 is an older standard that has been supported by all modern browsers for well over a decade. You'll also notice that there's no type annotation in the JavaScript output. The type is only used by the TypeScript compiler to do its checks. Once compiled, the type information is removed, because JavaScript doesn't support types natively. Alright, let's talk about creating a configuration file for the TypeScript compiler. In the terminal, we run tsc.init. This creates a configuration file called tsconfig.json with some default settings. Now let's close the terminal and open the tsconfig.json file. In this file, we have a number of settings, and as you can see, most of them are commented out by default. We're only going to use a few of them, so don't be intimidated by the full list. You don't need to learn all of these settings. In fact, nobody knows all of them, not even me. Let's go over a few of the important ones in this lesson. The first one is target, which specifies the version of JavaScript that the TypeScript compiler should generate. By default, it's set to S 2016, which is an older version that's supported by all modern browsers. Now let's look at the root dir setting under the module section. This defines the directory where your source TypeScript files are located. By default, it's set to which represents the current folder. However, it's common practice to place your source code in a dedicated folder. So let's go to our project panel, create a new folder called src, and move index.ts into it. We can also delete the index.js file, since we don't need it for now. After that, we'll change the root dir to src. There's also the out dir setting under the emit section. This specifies where the compiled JavaScript files should go. Let's enable this setting and change the value to dist. That way, our output will go into a separate distribution folder. Another useful setting is remove comments. If we enable this, the TypeScript compiler will remove all comments from the output JavaScript files, resulting in cleaner and smaller code. And finally, one very important setting is no emit on error. By default, even if your code contains errors, TypeScript will still generate JavaScript files. This isn't ideal. So it's best to enable this option to prevent any JavaScript from being generated when there are TypeScript errors. That way, you're not shipping broken code by mistake. Now, with this configuration file in place, we can go back to the terminal and simply run tsc. No need to specify individual files. TypeScript will automatically compile all .ts files in the project. Once you run it, you'll notice a new folder called dist, which contains the generated JavaScript file. So that's the basics of the tsconfig.json file. JavaScript comes with a few basic types like number, string, boolean, null, undefined, and object. TypeScript builds on top of this and introduces additional types such as any, unknown, never, enum, and tuple. As we go through this section, we'll dive into each of these in more detail. Before we start breaking them down, let's take a look at how we can work with primitive types in TypeScript. Head over to your index.ts file and clear any existing code. Let's start fresh. Now, let's declare a variable called sales. We'll explicitly set its type to number and assign it a large value, like this. In TypeScript, you can use underscores to separate digits in large numbers to make them more readable. It doesn't change the value, it's purely a formatting choice for clarity. Next, let's declare a string variable and a boolean variable. Now, here's something really neat about TypeScript. You don't always need to annotate variables. TypeScript can infer the type of a variable based on the value it's assigned. For example, if we remove the number annotation from the sales variable, TypeScript still understands that it's a number. Just hover over the variable in your editor, and you'll see the inferred type. Let's simplify our code a bit. Hovering over any of these variables in your code editor will confirm their inferred types. But what happens if we declare a variable without assigning a value? Like this. In this case, TypeScript assumes that the type is any, which means the variable can hold any kind of value. In TypeScript, there's a special type called any. It can represent any kind of value, a number, a string, an object, an array, and so on. When you declare a variable without assigning an initial value, TypeScript assumes that it's of type any. This means you can later assign values of different types to the same variable, and the compiler won't complain. While this offers flexibility, it goes against the core purpose of using TypeScript. The main reason we use TypeScript is to benefit from type safety, the ability to catch errors at compile time. When you use the any type, you lose this benefit entirely. As a rule of thumb, you should avoid using any as much as possible. Of course, there are situations where it may be necessary, for example, when migrating a large JavaScript codebase to TypeScript, and the exact types are not yet known. But even then, use it carefully, and only where truly needed. TypeScript may show a warning that a function parameter or variable implicitly has an any type. This means you didn't explicitly specify a type, and the compiler couldn't infer it. To fix this, you can either define the type yourself, or change the compiler settings. There's a way to globally disable these warnings by changing a setting in the TypeScript configuration file. However, doing this turns off one of the key features of TypeScript static type checking. It's not recommended unless you really know what you're doing and have a very specific reason. In JavaScript, arrays are dynamic, meaning they can contain elements of different types. For example, a single array can hold numbers, strings, or even objects, all mixed together. While this flexibility is powerful, it can also lead to unexpected bugs, especially when passing arrays to functions that expect values of a specific type. This is where TypeScript comes in. With TypeScript, you can apply type annotations to arrays to make sure they contain only the expected types, such as an array of numbers, strings, or any other specific type. If an element of the wrong type is added, TypeScript immediately flags it as an error at compile time, helping you catch issues before you run the code. In many cases, you don't even need to explicitly annotate the type. If the array is initialized with values of a consistent type, for instance, all numbers TypeScript can automatically infer the correct type. This reduces the need for extra typing, while still ensuring type safety. However, when dealing with empty arrays, the situation changes. Without an initial value, TypeScript assumes the array is of type any, which defeats the purpose of type safety. In such cases, it's important to explicitly specify the type of array you want to work with. Another great feature of using TypeScript with arrays is code completion, also known as IntelliSense. Because the editor knows the type of each element, It can offer relevant suggestions, show available methods, and highlight potential mistakes as you type something you don't get with plain JavaScript. All in all, TypeScript brings both safety and developer productivity when working with arrays, especially in larger or more complex projects. TypeScript has a type called Tuple, which is a fixed-length array where each element has a particular type. We often use them when working with a pair of values. Let's say for each user we want to represent two values, an ID and a name. So, we declare a variable and annotate it using a special syntax like this. First we add square brackets, and then tell the compiler that the first element is going to be a number, whereas the second element is going to be a string, and then we initialize our variable like this. So, we have a fixed-length array with exactly two elements, nothing more, nothing less. If we add a third element here, we get a compilation error saying type number, string. Number is not assignable to type number, string. Okay, so exactly two elements, and these elements should have these types. The first one has to be a number. So, if we pass a string again, we get a compilation error. Now, just like before, here we get IntelliSense, or code completion. So, if we access the first element, we see all the methods of number objects, and if you access the second element, we see all the properties and methods of string objects again. One of the reasons I love TypeScript. Now, one thing you need to know about tuples is that internally, they're represented using plain JavaScript arrays. So, if we compile our code, we're just going to see a regular JavaScript array. Let me show you. So, in the terminal, let's run tsc. Good. Now, back in our project here. In this folder, let's open index.js. Look, we just have a regular JavaScript array. So, that means back in our TypeScript code, if we type user.period over here, we can see all the methods of array objects. Now, one of these methods is a little bit troublesome, and that is the push method. So, we can call this method and store a third value in this array, and the compiler is not going to complain here. So, a tuple is a fixed-length array where each element has a particular type. Now, as a best practice, I would say restrict your tuples to only two values, because anything more than that is going to make your code a bit hard to understand. TypeScript has another built-in type called enum, which represents a list of related constants. If you know Java, you have seen enums before. We have the exact same concept here in TypeScript. So, let's say we want to represent the size of t-shirts as constants. One way is to define three constants like this: small, medium, and large. That's one way, and then throughout our code, we can reference these constants. Another way is to group these constants inside an enum. So, we use the enum keyword, then give our enum a name. Now, note that here I'm using Pascal naming convention, so the first letter of every word should be uppercase, okay? Then we add curly braces, and inside the braces, we add our members: small, medium, and large. Once again, I'm using the Pascal naming convention for the members. Now, when we define an enum, we don't need to define these three constants anymore. By default, the TypeScript compiler assigns the first member the value of 0, and other members values like 1, 2, and so on. Now, if you don't want to use these values, we can explicitly set values. So, we can set small to 1, and then medium becomes 2, and large becomes 3. We can also use string values like s. If we do this, then we have to explicitly set a value for each member, so medium and large like this. Now, I'm going to revert this code and just rely on numbers. So, I'm going to initialize small to 1 and rely on the compiler to set the value for other members. So, now that we have this new type, we can declare a variable like mySize of type size and set it to size.medium, okay? So, this is how we can use enums. Now, let's see what happens if we log mySize on the console. So, back to the terminal, let's run the TypeScript compiler. Good. And then use node to execute our JavaScript code. So, we go to the dist folder and pick index.js. So, look, we see the numeric value associated with our enum member, okay? Now, let's look at the generated JavaScript code in this file. So, back to the project. Here's our index file. Take a look. So, the generated JavaScript code is pretty verbose. It's pretty lengthy. Now, you don't need to worry about understanding this, but let me show you a trick. Back to our TypeScript file. If we define this enum as constant, the compiler will generate a more optimized code. So, let's recompile our code, and then look at index.js one more time. Now, we don't see all that code anymore. We only have one line for setting mySize to 2. Again, you don't have to worry about the generated JavaScript code. All I want you to take away here is that using an enum, we can represent a list of related constants, and if we define our enums using the constant keyword, the compiler will generate more optimized code. Let's talk about how TypeScript helps us prevent common problems when working with functions. So, let's define a function called calculateTax and give it an income parameter of type number. Now, let's hover our mouse over the function name. Look at the type of the return value, it's void, meaning this function does not return a value. If you return a value here, like a number, now the type of the return value is number. So, the TypeScript compiler has inferred the type of the return value for us, and that's great. But, as a best practice, we should always properly annotate our functions, so all the parameters, as well as the return type, should be properly annotated, especially if you're building an API for other people to use. So in this case, to annotate the return type, we go after the list of parameters, add a colon, and specify the return type like number or void if we are not going to return a value. So let's add number. Now, this has an extra benefit if you forget to return a value, or if you return a different kind of value like your string, we get a compilation error immediately. So as a best practice, always properly annotate your functions. Now, let's temporarily return 0. Okay, look at the income parameter. This is an unused parameter. Now, we have a compiler option for detecting these unused parameters. So, let's go back to our tsconfig.json file. In the type checking section, we have a compiler option called no unused parameters. We have to explicitly turn this on, because this setting is not part of the strict setting. Now, back to index.ts. Look, we have a warning saying income is declared, but its value is never read. So, let's change this code and say, if income is less than 50,000, then we're going to return income asterisk 1.2. Now here, we have another compilation error saying, function calculate tax is missing return statement, and return type does not include undefined. It sounds a bit cryptic, but what this error is saying is that if this condition is true, we're going to return a number. Otherwise, as you know, JavaScript by default always returns undefined from our functions, and undefined is not a number. Now, let me temporarily remove the annotation for the return type. Look, we have no compilation error, but this function has a problem. If the income is greater than 50,000, we're going to get undefined from this function, and this may cause a bug in our application. The good news is that we have another compiler option for detecting these kinds of issues where we forget to return a value. So back to our tsconfig.json file again, in the type checking section, we have a setting called no implicit returns. Again, we have to explicitly turn this on, because this is not part of the strict setting. Okay, now to factor code, we have a warning saying not all code paths return a value. So now we can fix this problem and say, otherwise, if income is greater than 50,000, we're going to return income asterisk 1.3. But again, it's best to always annotate our functions properly to prevent all these issues, so we should always return a number from this function. Now, we have another useful compiler setting for detecting unused variables. So if we declare a variable like x and don't use it in this function, this is unused. Now, using the TypeScript compiler, we can find these issues in our code. So back to tsconfig.json. Here is the setting no unused locals. With this feature enabled, now back to our code, we have a yellow warning saying x is declared, but its value is never read. So now, we can delete this and make our code cleaner. So this is the basics of functions. Now, let's add a second parameter here, called tax year of type number. Now, we have a warning here saying tax year is declared, but its value is never read. So let's change our condition to, if tax year is less than 2025, then return income asterisk 1.2. So now, with these two parameters, if you want to call this function, we have to supply exactly 2 arguments, nothing more, nothing less. So I'm going to pass 10,000 for the income and 2025 for the tax year. If you add an extra argument here, we get a compilation error saying, expected 2 arguments, but got 3. If you have been coding in JavaScript for a while, you know that this is valid JavaScript code, so JavaScript doesn't really care how many arguments we pass to a function. We can pass more or fewer arguments than the number of parameters, but TypeScript is very strict about this. So here, we should pass exactly 2 arguments. But what if you want to make this optional? Let's say in some places we want to call this function without supplying the tax year. Well, we can make this parameter optional by adding a question mark right here. Now, we have a compilation error on this line saying, object is possibly undefined. So, if we don't supply the tax year, by default, undefined will be used, and we cannot compare undefined with 2025. So here, we have 2 options. One option is to use the old JavaScript trick, so we wrap this in parentheses, and then, using the OR operator, we give it a default value like 2025. So, if we don't supply the tax year, this value will be used. Otherwise, the argument that we pass will be used here, okay? Now, I don't like this approach. There is a better way. We can give this a default value. So instead of making it optional, we give it a default value like this. Now, we can call this function with or without a tax year. If we don't supply an argument for the tax year, this value will be used. Otherwise, what we pass here will overwrite the default value. Alright, the last thing we're going to cover in this section is objects. So, let's declare an employee object with an ID property. Now, you know that in JavaScript, objects are dynamic, so their shape can change throughout the lifetime of our programs. So once we have an employee object, then later we can give it a new property, like name, and this is totally valid in JavaScript. But as you can see, this is not valid in TypeScript. The compiler is saying, property name does not exist on this type. So this type is an object with an id property, which is a number. So just like all the variables we have declared so far, the TypeScript compiler has inferred the shape of this employee object. So if you hover our mouse over employee, we can see its shape. It's an object with an id that is a number. Now, just like all the variables we have declared so far, we can explicitly apply a type annotation here. So after employee, we add a colon, followed by braces, and inside the braces, we define the properties of an employee object. So every employee should have an id that is a number and a name that is a string. Now, the previous error on this line is gone, but we have a new kind of error. Let's find out. The compiler is saying, property name is missing. So the reason we're seeing this is because every employee should have these two properties, but while initializing this object, we haven't supplied the name property. Now, here we have two options. One option is to set the name to an empty string. We cannot set it to null or undefined. We'll talk about this in the next section. So, we should either set it to an empty string, or we can make this property optional, and then we don't have to supply the name property while initializing an employee. Now, even though TypeScript allows us to do something like this is something we should avoid, because conceptually, it doesn't make sense to have an employee without a name. Every employee should have a name. It would make sense to make the fax property optional, because not everyone has a fax machine, right? So always make sure the code you write conceptually makes sense. Don't blindly use features of TypeScript or any other programming languages. Okay, so in this case, we're not going to use an optional property. And that means we should either set the name to an empty string or initialize it right here. Okay, now we have an error because I used a period. Okay, so now we don't need this last line anymore. Okay, now sometimes we want to make certain properties read-only so we don't accidentally change them later on. So with our current implementation, we can change the ID of an employee anytime, and this is not valid. This is where we use the read-only modifier. So we apply it before the name of the property, and now the TypeScript compiler prevents us from accidentally modifying the value of this property. Okay, good. Now, how can we define a function, or more accurately, a method in this object? Let's say every employee object should have a retire method. So, in our type annotation, we need to define the signature of this method. We need to specify how many parameters it's going to have, what is the type of each parameter, and what is the type of the return value. So we're going to have a retire method with one parameter that is date. Now, here we use the arrow function syntax. So first, we add parentheses, and inside parentheses, we specify the parameters. So, we're going to have a date parameter of type date. This is just a built-in date object in JavaScript and TypeScript. So, we only have one parameter. Then, we use a fat arrow. And here, we specify the type of the return value. We don't want to return any value, so we're going to use void. Now, we have a compilation error saying property retire is missing, because when initializing this object, we haven't supplied the retire method. So let's do that real quick. Alright, retire is going to be a method with one parameter. And over here, I just want to log the date on the console. Pretty simple. So, this is how we can work with objects. Now, I know this syntax, this type annotation, is a little bit messy. It's making our code a bit verbose or noisy. Alright, so this is the employee object that we created at the end of the previous section. Now, there are three problems in this implementation. The first problem is that if you want to create another employee object, we have to repeat this structure. We have to repeat this shape, so we'll end up duplicating our code, which is bad. We always want to conform to the DRY principle, don't repeat yourself. Now, the second problem is that the other employee object might have other properties. So these two employee objects might not have a consistent shape, because we don't have a single place to define the shape of an employee object. Now, the third problem is that overall, this structure is making our code a little bit hard to read and understand. This is where we use a type alias. Using a type alias, we can define a custom type. Let me show you. So, on the top, we start with the type keyword, then give our new type a name, and once again, here we use Pascal case, so employee with a capital E. Then, we set it to braces, and inside the braces, we define all the properties and methods an employee object should have. So, I'm going to go in this annotation, select these 3 lines, and by pressing Alt and up, we can move these lines up. Okay, now when defining this employee object, we annotate it with our new type, employee. Okay, so now we have a single place where we define the shape of an employee object, and we can reuse this in multiple places. This is the benefit of using a type alias. Alright, let's talk about union types. With union types, we can give a variable or a function parameter more than one type. So, let's define a function for converting weight from kilogram to pounds. Now, we give it a parameter called weight. Now, let's assume that this parameter can be either a number or a string, so we annotate it with number vertical bar string. So, using a vertical bar, we can create a union type. Now, we can call this function in 2 ways. We can give it a number or a string, like 10 kilograms. Okay, now let's finish up this example. So, we're going to annotate the return type and return a number. Now, in this function, at this point, we don't know if the weight is a number or a string. So, if we type weight, we only see the properties and methods that are common between numbers and strings. So, both numbers and strings have these 3 methods: to locale string, to string, and value of. So here, we are not seeing methods that are specific to numbers or strings. And this is where we use a technique called narrowing. So, we're going to narrow down this union type into a more specific type. So, here we can say if type of weight, number. Now, in this block, the compiler knows that the weight is a number. So, if we type weight, we see all the methods that are available in number objects. And by the way, we don't necessarily need the code blocks here in this line if you have a one-liner. And if we type weight, we still see all the methods available in numbers. Okay, so what are we going to do here? We're going to return weight asterisk 2.2. Otherwise, if you end up here, that means weight is a string. So now, we see all the properties and methods of string objects. Okay, so to finish this example, here we're going to return. First, we need to convert the weight to an integer. So we call parseInt, pass the weight, and then multiply it by 2.2. Okay, now back to the terminal. Let's compile our code and see what we get. Alright, we're going to go to index.js. Take a look. Our union type is not part of the generated JavaScript code. It's purely for the compiler to do its type checking. So, you learned that using a union type, we can say a variable or a function parameter can be one of many types, right? Now, we have another technique for combining types called intersection. So, instead of a vertical bar, use an ampersand. And now this type represents an object that is both a number and a string at the same time. Now, technically, this is impossible. We cannot have an object that is both a number and a string at the same time. So, let's look at a more realistic example. I'm going to use our type alias to define a new custom type called draggable. So, this represents an object that can be dragged on the screen. Now, what properties or methods do we need in a draggable object? Well, at least we need a method called drag, which takes no arguments and returns void. Now, similarly, we're going to define another type called resizable. And here, we need a resize method that should take 2 parameters like the new width and the new height. But for simplicity, let's get rid of all that noise and just add no parameters and say this method returns void. Okay, so now we have 2 separate types, and using an intersection type, we can combine them into a new type. So, we can define a new type called UI widget, which is draggable and resizable. So, this is an intersection type. Now, with this type in place, we can declare a variable called textbox, which is a UI widget. Now, to initialize this object, we need to implement all numbers of draggable and resizable objects. So, we need to implement the drag and resize methods. So, drag is a simple method, and so is the resize method. So, this is type intersection in action. Sometimes, we want to limit the values we can assign to a variable. This is where we use literal types. So, let's declare a variable called quantity, and assume that the quantity can either be 50 or 100, but nothing else. Now, here's the problem. If we annotate this with number, this can take any numbers, any valid numbers in JavaScript, right? So, to limit the values we can use here, we use a literal type. So, instead of annotating this with the type like number, we'll annotate it with a literal, meaning an exact or specific value. So, I'm going to replace number with 50. Now, quantity can only be set to 50, nothing else. So, if you set it to 51, you get a compilation error. Now, you might think this is not useful. Well, that's true. But what if we apply the union operator here? So, we can say the quantity can be 50 or 100. Now, we can set it to 50 or 100, right? But we're not done yet. We can make this code even better. So, instead of hard-coding these literal values here, we can create a custom type using a type alias. So, we define a new type called quantity, which can be 50 or 100, and then we annotate our variable with our new type. So, what we have over here is called a literal type. Now, literals don't have to be numbers. They can also be strings. For example, we can define a new type called metric, which can be centimeter or inch. Okay, so that's all about literal types. Next, we're going to talk about nullable types. All right, let's talk about working with null values. By default, TypeScript is very strict about using null and undefined values because, as you probably know, these values are a common source of bugs in applications. So, let's look at a real example. Let's define a function called greet that takes a parameter name, which is a string. In this function, we just want to do a console, log, and print name to uppercase. Now, in vanilla JavaScript, we can call this function and accidentally give it null or undefined. That is totally valid JavaScript code, but when we run our program is going to crash because we cannot call this method on a null or an undefined object. So, this is why null and undefined values are a common source of problems, and that's why by default, the TypeScript compiler stops us from using null or undefined values. Here we have an error saying, argument of type null is not assignable to parameter of type string. Let me show you where this comes from. So, let's go to our tsconfig.json file. In the type checking section, we have a compiler option called strict null checks. This is enabled by default as part of the strict option. So, if strict is set to true, then strict null checks is also true. But we can override it and turn off this feature. Now, back to index. TS, the error is gone. So, this is why by default TypeScript is very strict about using null values. Technically, we should never use this option. We should never turn it off. So, I'm going to rewrite this back. But what can we do in this function? What if we want to have the ability to use a null value? Perhaps if we don't have a name, you want to print just a generic message like hola, meaning hi in Spanish. So here we can say, if name is truthy, meaning it has a value, then we're going to print name, uppercase. Otherwise, if it's null or undefined, we're going to print hola. Okay, but we cannot pass a null value here yet. This is where we use a union type once again. So, we annotate this parameter with string vertical bar null. Now, we can pass a null value, but we cannot pass undefined, because this is not a valid value for this parameter. If you want to have the ability to pass undefined as well, again we're going to use the union operator. When working with nullable objects, we often need to perform null checks. For example, let's define a type alias called customer with a property birthday of type date. Next, we define a function to get a customer from a database by an id of type number, which returns either a customer or null if no customer exists with that given id. In this function, if the id equals 0, we return null. Otherwise, we return a customer object with a birthday. Now, let's declare a variable and call getCustomer with 0. If we want to print the customer's birthday using console.log customer.birthday, we get a compilation error because the customer might be null. One way to fix this is by checking if the customer is not null before accessing its properties. Taking this further, assume the function might also return undefined. Now, we add undefined to the return type, and we have to expand the if statement to check that the customer is neither null nor undefined. Although this works, there is a simpler way in TypeScript using the optional property access operator. Because the customer might be null or undefined, we add a question mark before the dot when accessing the property. This means that the property access only happens if the object is not null or undefined. Otherwise, the whole expression returns undefined safely without errors. If we pass 0, we get null, so the expression evaluates to undefined. If we pass 1, we get a valid customer object and print their birthday. This is the optional property access operator in action. We can take this further by making the birthday property optional. If we want to print the full year of the birth date, we call .getFullYear on birthday. Again, this may cause a compilation error because birthday might be undefined. To fix this, we use the optional property access operator again before calling .getFullYear, ensuring safe access only if birthday exists. There is also an optional element access operator, which is useful for arrays. If we have an array of customers that could be null or undefined, before accessing the first element, we can use a question mark before the square brackets. This lets us safely access the first element if the array exists, or get undefined if it does not. Finally, there is the optional call operator. If we have a variable that might reference a function or be null, calling it directly could cause a runtime error. Instead, we use the optional call operator, which is a question mark after the variable, before the parentheses. This calls the function if it exists, or safely returns undefined if it does not. Thanks for watching. If you want new course where I will build project with React and TypeScript, press like and subscribe.